Okay, here we go. So a couple things just to wrap up. We got through most everything on Tuesday, but there's a couple things we still didn't quite get to. We're finishing up factoring quadratic trinomials. So recall we did two, there were two ways that we factored trinomials where a was not equal to 1, right? Remember we used grouping, which is my preferred method, and then we used slip and slide. So let's take a quick look at slip and slide just to remember how we do this. So do you remember the steps here? Let me get everybody real quick, everybody just up here looking at this. I'll get you going on your work in just a second. So what are we going to do first here on this one? Good. We always want to try to get a greatest common factor first. What can we undistribute here? 3x. Good. There we go. Okay. So right away we could factor out a 3x. So we got a 3x out front. Now what's left behind if we do that? If we undistribute a 3x, what are we left with from the first term? Everybody agree? 6x squared. Next term? 11x. There you go. And then the last term? Minus 10. Okay, good. So we pulled a 3x out front, factored out a 3x. We're left with a trinomial there that where a is not equal to 1. So this is a harder type, right? Let's use slip and slide. So if we're going to use slip and slide, what's our first step? Remember?
Would it be a times c?
Right. So first step, we're going to take the a and we're going to drag it over to the end, right? So looks like this. First step, slip a to the end of the trinomial and multiply by c, right? So we're going to take this 6, drag it over there and multiply by the 10. So then we're just going to work, this is the reason I don't like slip and slide, because I can't just set all these steps equal to each other. We're going to have to kind of forget about the 3x temporarily, and we're just going to factor this using the steps of slip and slide. So step 1 of slip and slide, we get x squared plus 11x minus 60, right? Okay. So now, what's next? Okay, good. So now we've created this simple or this basic trinomial where a is equal to 1. So we'll just factor that regularly. We want to find magic numbers that multiply to c and add to b, right? Okay, so what are our magic numbers? They've got to multiply to negative 60 and add to 11. So what can you tell me about the signs of those then? If they're going to multiply to a negative, what's that telling us? If two numbers multiply to a negative, what's that tell you about the signs of the numbers? Good, one's negative, one's positive. If they add to a positive, which one's bigger? The positive is good, because it cancels the negative with some to spare, right? Okay, so then we end up with, in step 2, we know we've got our x's there, right? But our magic numbers were, what'd you guys tell me? Oh, you didn't tell me what they were yet. What are they? So we know we're getting a positive and a negative. Now, what are the numbers that multiply to negative 60 and add to 11? I have to think about that one a little bit. What do you think? Okay, there we go. Good. Positive 15 and negative 4. Okay. Next step. What do we do next? Remember? Divide what? Divide the magic numbers by A, right? So next step, we're going to divide both of our factors. And by factors, that's a little confusing. For us, instead of saying factors, whoops, that's our magic numbers, right? Divide each of the magic numbers by, kind of color code these here. Whoops, no, I got that backwards. That was purple, wasn't it? Color code each of these steps. So step 3, we're just going to divide each of the magic numbers by A, which was 6, right? Okay, makes sense. Step 4, what's kind of our last step here? We got sort of 2 parts to the last step. Remember what we do? What do we do on that last one? Slip and slide. What do we have to do to those fractions?
Oh, you gotta put their denominator in front of x.
Good, we got to reduce fractions if we can. And then if there are still denominators, we slide it up in front of the x, right? So it looks like this. So step 4. We're going to reduce the fractions. So I could divide each of those numbers in the first fraction by what? 3. So I get 5 halves. Each of the numbers in the second fraction I divide by, good, you get 2/3. And then last step, if there's a denominator, we slide it up in front of the x, right? And so then we end up with this trinomial factoring into 2x plus 5 times 3x minus 2. And don't forget, we've still got that 3x out front, don't we? Right there, our GCF that we pulled out before we started even messing with the trinomial. So there's our answer. Okay, we're good with that? That all make sense? Okay, last thing I want to show you here. There's just a couple kind of bonus problems at the end of the assignment, and that's what these relate to, these last couple questions. So what about one like this? What if we have multiple variables in there? If I have x's and y's, this is a case where factoring by slip and slide really is kind of cumbersome. It's easier just to go back to our grouping technique for something like that. So let's take the same problem and let's factor by grouping. Okay, so remember what we do with grouping. We've got to, when we factor by grouping, we're going to see if we can factor out any GCF, which we can't do. Okay, now we got to find magic numbers, right? We've got to find magic numbers that multiply to A times C. Okay, so in this case, what are they going to multiply to? What are they going to multiply to? And we're not going to include the variables. Our A and C are just going to be the coefficients, right? So negative 24. Everybody agree? They multiply to A times C, which in this case is 8 times negative 3. That's negative 24, okay? Multiply to negative 24, and they have to add to what? B, which is negative 2. Okay, so what 2 numbers do that? What 2 numbers multiply to negative 24 and add to negative 2? We'll call them M and N. We know they got to be opposite signs. The negative's got to be a little bit bigger, right? Because they add to a negative. So what do you get? Multiply to negative 24, add to negative 2. I think There you go. Good. 6 and 4. So -6, +4. Okay, so that's how we're going to split our b up, right? Our b is going to get split up into a -6 plus 4. Okay, so then you can see this is going to work out just fine with grouping. So we get our 8x squared out front. We get our -3y squared at the end. And that middle term, we're going to split that thing up into a -6xy plus 4xy, right? We're going to break that coefficient up. And so maybe there's a middle step I'll just include in here, right? So we know in between here, our little middle step is that -2xy, whoops, what did I do? I didn't do that. There we go. Our -2xy is equal to -6 plus 4xy, right? Which is the same as -6xy plus 4xy. And we'll split this thing right down the middle. Okay, this is kind of a little tricky, right? So now we're going to factor by grouping. What's the greatest common factor in the first group? What do you get for the greatest common factor in that first group?
2.
2.
-2.
Well, no, 2 is fine, but what else?
X.
X, good. I could undistribute an X also, couldn't I? So my GCF there is 2x. What's the binomial that remains behind when I factor that out? Well, to find out, I could just divide each of these through by 2x, right? That's what I'm undistributing. And what do I get when I do that? 8x squared divided by 2x is what? 4x. Okay, good. Now let's see if that makes sense. 2x times 4x, yeah, that's 8x squared, isn't it? -6xy divided by 2x. Everybody agree the x's cancel? So I'm going to get a -3y. And now remember, we've got this plus sign that separates the groups. In group 2, remember what has to happen with grouping. What factor? I know I'm going to get a GCF, something that I can factor out, and the leftover binomial factor. Which one of those has to be the same in the two groups? Remember how that works, factoring by grouping? Remember that the remaining binomial factor in group 2 has to be the same as the binomial factor in group 1. Those always have to be the same. So immediately I can just write 4x minus 3y there. Okay, well, what do I have to undistribute from group 2 to make that happen? What times 4x is 4xy? Y. Okay, good. And we can check it now. It always is going to work. If I distribute the y, I get my 4xy, and I get my -3y squared. So it works, doesn't it? Right? So now look at this. I've got group 1 and group 2, and each group is a combination of two factors, and we have a common factor that we can undistribute, right? So if I undistribute the 4x minus 3y from both groups, what's left behind? Well, let's see. If I divide each group by 4x minus 3y, don't those cancel? Right? And so I'm left with, first group, I'm left with 2x. I've got my plus in the middle. And if I divide the second group through by 4x minus 3y, it cancels, and I'm just left behind with a y. So it works. We got it. Final answer just looks like 4x minus 3y times 2x plus y. So even for those really tricky ones, where we're factoring trinomials that have both x's and y's, and that's tricky, this factoring by grouping works. Okay? All right, any questions? Okay, I'm gonna let you go. You guys can work on this stuff. Is there anybody that hasn't gone through their test with me yet that would like to? You want to, Crystal? Okay, let's do that. Let me finish, get this thing stopped up here, and you can come up and we'll go through.